Let's do section 9.4, page 471, exercise 6, which reads, evaluate the improper integral or state that it diverges. And for exercise 6, we have the integral from 1 to infinity of 2 dx over x cubed. Now let's start off by looking at what the graph of this looks like. And we've got something that looks like this, and somewhere around here is going to be x equals 1. Now this is a graph that kind of trails out to infinity without ever really reaching the x-axis. And one of the things that we need to learn in this section is that we are not allowed to have a limit of integration that is plus or minus infinity. So the first definition in this section tells us how to address this problem. So integrals with infinite limits of integration are called improper integrals. And we have 3 cases here that we can discuss. So number 1, if f of x is continuous on the interval from a to infinity, then the integral from a to infinity of f of x dx becomes the limit as b goes to infinity of the integral from a to b of f of x dx. Number 2, if f of x is continuous on the interval from negative infinity to b, then the integral from negative infinity to b of f of x dx becomes the limit as a goes to negative infinity of the integral from a to b of f of x dx. So basically what we're doing is replacing that plus or minus infinity with some variable, a or b in this case, and then letting a or b go to plus or minus infinity respectively. So finally, in case 3, if f of x is continuous on the interval from negative infinity to positive infinity, then the integral from negative infinity to positive infinity of f of x dx is equal to the integral from negative infinity to c of f of x dx plus the integral from c to positive infinity of f of x dx, where c is any real number. And once we get to this point where we're adding those 2 integrals together, we go back and apply either 1 or 2, depending on which integral we're looking at. So let's go back to the problem that we are looking at, and we've got our integral from 1 to infinity of 2 dx over x cubed. And as we said, we're not allowed to have infinity in our limits of integration. So we're going to turn this into the limit as b goes to infinity of the integral from 1 to b of 2, and I'm going to make this x to the minus 3 dx. And of course we know what the antiderivative of that's going to be. So we're going to have the limit as b goes to infinity of 2 times x to the negative 2 divided by negative 2 and evaluated at 1 and b. So this is going to give us the limit as b goes to infinity of negative 1 over x squared evaluated between 1 and b. And now we're ready to substitute in. So we're going to have the limit as b goes to infinity of negative 1 over b squared minus negative 1 over 1 squared. And when we rearrange this a little bit, we're going to have the limit as b goes to infinity of 1 minus 1 over b squared. And when we actually substitute in for the limit, when we let b go to infinity, 1 over b squared is going to go to 0. And that means that our integral is going to be equal to 1. Now obviously if the limit exists, the improper integral converges. And if the limit doesn't exist, the improper integral diverges. And because our integral here from 1 to infinity of 2 over x cubed dx is equal to 1, that means that the improper integral converges.